Okay, so unlike ionic compounds, molecular compounds uh, have much more variation, right? So with molecular compounds, the different atoms can form many different kinds of compounds, and so we need to use prefixes, and we do use prefixes like di, tri, and so on. Carbon dioxide, carbon monoxide, because carbon and oxygen mix together, but they don't always form the same ratio like ionic compounds do, right? So our learning goal for this section is to given a particular formula of a molecular compound, write its name, or given its name, write its formula. So, as a brief review, molecular compounds form when atoms of two or more nonmetals share electrons, making covalent bonds, right? So if you got a bunch of nonmetals, you're going to have covalent bonds. Valence electrons are shared by nonmetals to achieve stability, which we've described in previous conversations. And it turns out a molecule is a discrete group of atoms in a definite proportion. That is, a molecule is maybe, in the case of carbon dioxide, two oxygen atoms and one carbon, and they stick together as they do their business. Okay, so let's talk about naming them now. When naming a molecular compound, the first nonmetal in the formula is named by its element name, just like we did for the cation with ionics. The second nonmetal is named using the first syllable, but we follow it like we did with ionics. We take the ending off and put "ide" in this place. Okay. When a subscript indicates two or more atoms of an element, a prefix is shown in front of its name. So, for example, you can have CO2 or you can have CO, right? Because they're both nonmetals, they show up in different proportions. So the CO2 is carbon dioxide. CO is simply carbon monoxide. The number of oxygen atoms present is indicated by the prefix. You can see that, right? There's my 2, di, and there's an understood 1 right there, right? CO, so that's carbon monoxide. Now, it's important to appreciate that when the vowels O and O or A and O appear together, the first vowel is omitted. So, for example, I might have said mono oxide, right? But I've got two O's together, and so I get rid of that. So I say monoxide, right? Carbon monoxide, not carbon monoxide. All right, so here's some examples of some covalent compounds. Carbon dioxide, this is from your textbook, table 6.11. Carbon dioxide, using fire extinguishers and so on. CS2, manufacture of rayon, nasty stuff. Nitrogen oxide, this is a stabilizer, and it's also a biochemical messenger in cells. This is real interesting. Extremely rare to have such a small biochemical messenger in cells, but that's, yeah, I think of biochemistry every time I see that. N2O is dinitrogen oxide, right? And SF6, sulfur hexafluoride. Got it? All right. Those are just examples. I wouldn't memorize those. I would get used to the rules, and we would and become familiar thereby. So, naming molecular compounds. Let's do a practice here. Pause the video and come up with a name for this. Okay, so I'm gonna suppose that you paused it. I'm gonna show you how I'm gonna do this. I'm gonna say nitrogen. The two elements, nitrogen and chlorine, right? And we take the second one and we change it to chloride. No big deal. And then we go, oh, there's 3 of them there. And since these are both nonmetals, I got to say nitrogen trichloride. Okay, let's do another one. Pause the video and do the same thing here with this. Okay, I'm going to suppose that you paused it. And I'm going to show you how I'm going to do this. I'm going to say I've got boron and oxygen, right? I get rid of that and put ide. Okay. And I see I've got a 2 here, so it's going to be diboron trioxide. And that is correct. Okay. So writing formulas from the names of molecular compounds. In the name of a molecular compound, the names of 2 nonmetals are given along with prefixes for the names of atoms of each, which we've done. To write the formula for the name, use the symbol for each element and a subscript if a prefix indicates 2 or more atoms. Okay? So let's do, it's just the backwards what we were doing before. So diphosphorus oxide, pause the video, and write the formula for this. Okay, so I'm going to suppose that you did pause it, and I'm going to say oxide comes from oxygen, and phosphorus comes from there, right? And it's going to be diphosphorus pentoxide. And that is the formula for diphosphorus pentoxide. Okay, so the last thing I want to discuss here is you have to decide, if you're looking at a compound, how you're going to name it. You got to decide if it's molecular or ionic, or if it's covalent or ionic, right? And how do you do that? Well, it's not really complicated. You're really looking for a metal. If a compound has a metal in it, or a polyatomic ion, then it's ionic, right? Potassium is a metal, right? And so therefore, potassium oxide is ionic, okay? It's covalent if the first element in the formula is a non-metal, right? And so N2O, which looks a lot like K2O, right? They look a lot the same, but N is a non-metal, and therefore it is covalent. Okay, and so you'll be using the molecular rules for naming compounds. We need to get a lot of practice with this. It gets easy, but it's going to take some practice. Good luck.